And then we can have a look at this task 20, which is about network analysis, circuit calculation, circuit analysis, however you would like to call it. And you can see it's a 2-star task, so it's not too simple, but it should also be not too complicated. And we have a circuit with, once again, what is this here? What is this for a symbol? This is the current source. So we have 2 current sources and 2 resistors. 4 resistors, 2 current sources and 4 resistors. And luckily we have all the values given. So it's everything from 10 ohm to 40 ohm and 5 ampere and 6 ampere for these current sources. And then you can already see, okay, these are somehow made up values, 1 to 6, that just came to someone's mind. And so, yeah, what's maybe the difficulty with the circuit? What's the problem why we cannot really solve the circuit with the methods that we had before? Like current, yeah, because there are 2 sources. And so this source has some influence on the circuit, the second source has some influence on the circuit, and so now somehow we need something that in addition to what we had before, like putting resistors in parallel and in series and having current and voltage divider rule, we need some methods to solve circuits like this. And what is suggested here is in task A, doing it by a superposition. And I would suggest to start with this one. So I will use blue for subtask A. And yeah, we just shortly talked in the lecture what superposition means. Does anyone remember what it means? What was the idea of this superposition method? What was the problem that you just said with the circuit? There are 2 sources. And so the idea of the superposition method is we just...
The sources separately?
Exactly. We look at the sources individually. And so we need to switch off then the other source. So we only switch on one source and switch off all the other sources. Of course, for 2 sources, it does not make a difference, but I think one student in one exam made it in the wrong way, and he always switched off one source and let all the other sources be switched on. Yeah, so for 2, it does not make a difference, but for the real idea is switch on one source, switch off all the other sources, and then do this for each source individually. And so the question is, if we switch off a source, so if we take like this current source and switch it off, so what will happen? What will the current source turn into if we switch it off? And the same is the question, if we would have a voltage source in our circuit, and if we switch off the voltage source, what will happen? What will the voltage source will turn into?
Voltage source will be short, and current source will be like a huge resistor.
Yeah. So the voltage source will turn into a short circuit, and the current source will turn into an open circuit. And so let's say the rule of thumb, or what you can easily remember, is if you turn off the source, you just delete, let's say, this circle. And if you delete the circle, this will be an open circuit. And if you delete the circle here, if you would just delete the circle, then it would turn into a short circuit. Okay, so here we have current sources. The current sources will turn into an open circuit. Okay, so then the next step is we take a look at the circuit for only the first source. Let's start with this one here, the source 6. is switched on. And so in this case, I can maybe redraw the circuit, but it looks pretty similar, of course. So here we have the source, and the source is feeding this current here in the upside direction. And then we still have the 4 resistors. So first resistor, second resistor, and the third and the fourth resistor. So this is R1, this is still R2, this is R3, and this is R4. And what we are looking at is the current I1 that goes here into this direction. And of course there's some junction and some node here and there. Okay, so this current source turned into this open circuit, and now we have a circuit once again that has just one source, so no problem to calculate this. And what rule, what formula can we set up, can we use to calculate this current here? Current divider. So we can set up a current divider, and then the question is, how do we get this partial current from this total current?
Like I1 is I source 6 times the right side, so R4 plus R3 plus R4 divided by all of the resistance.
Exactly. So it's the resistance of the other branch divided by the total resistance of this mesh. And this is R1 plus R2 plus R4 plus R3, or R3 plus R4. And so we can just insert all the values. This is 6 ampere, and then we have 30 and 40 is 70 ohm. And here we have the total sum of them, and this is 100 ohm. And then we see, yeah, it's not the nicest values here for calculation. Yeah, so it's something like 6 times 70 divided by 100. So it's, yeah, 4.2 as you said. 4.2, and the unit will be ampere. Okay. So this source will feed 4.2 ampere into this direction through this resistor. Okay, so what is the next step then? Just look at the influence of the second source. So let's switch on only IS5. And so now we have this source turned on, this source is switched off. It will turn into an open circuit, as we said, so we could delete the whole connection here. And I will, for simplicity, redraw the circuit, and I will redraw the circuit in a similar way like here, that I put the source IS5 once again on this side, so that it's feeding a current, pushing a current in the upside direction. This is IS5. And yeah, then we can see, okay, then we have this junction here, this node, and then the current can split up and can go over R3 and R1, and it will go back to the source, or it can go the other way over R4 and R2, and then it's also back at the other end of the source. So we have R3 and R1, or the other way would be R4 and R2. And it's not really necessary, of course, to redraw the circuit like this, but I think in this case it's rather useful, because then we can see, okay, it's the same circuit structure, just that the resistors are arranged in a different way. And so we are still looking for this current, and this current is the one that goes from R3 over R1 back to the source. So from R3 over R1 back to the source. So it's still this very same current here. So how can we calculate this current? With the same current divider as before. Above the fraction bar. So I1 in this case is the total current, which is IS5. And so then, as said, the other two resistors, the other branch is R4 plus R2, and the sum of all the resistors is still the same as before. And so we can insert the values. This is 5 ampere. And then these two are 60. So we have 60 ohm divided by the same 100 ohm as before. And so 5 times 60 is 300. 300 divided by 100 is 3 ampere, right? Okay. So yeah, you can still somehow see it. Okay, so now we come to the last and important step here, the superposition. So we say this is the current, let's say, from the source 6. This is the current from the source 5. And so our total current I1 will be the superposition of the influence of this current that is fed or powered by the one source and the other source. And so 4.2 ampere plus 3 ampere at the end is 7.2 ampere. And so, yeah, then this is the current at this position in this circuit that is powered by these two, or that is generated by these two sources in this case. And as you can see, the advantages, it works with what we have learned before, current and voltage divider, series and parallel connection, and so on and so on. The disadvantage, let's say, is it only allows us to calculate one current or one voltage somewhere. Of course, you could also now set up rules for the other currents and voltages, but then you have quite a large effort to have like all the rules for all the currents and all the voltages for each of these 2 or 3 or whatever number of sources that you have in the circuit. And there's also another prerequisite. This superposition, of course, only works if you have a linear network. If you have some nonlinear element somewhere, if you have a diode or a transistor or something like this, then this method won't work, because you need linear elements for the superposition to work.